Thousands of years ago, the Romans perfected transporting water from faraway sources via aqueducts, which were channels built underground and sometimes more famously above ground to improve their quality of life with a steady supply of fresh water. The term aqueduct means to conduct water, which is what water pipelines do. Today, our use of water pipeline is one of the most important parts to every irrigation system. We call the network of piping in the ground for these systems mainlines and laterals.
The word mainline is used to define a pipe that's upstream of the zone valves. It will normally be the largest pipe on the job. Laterals are pipes that are downstream of the remote control valve, and it is the laterals that deliver water from the valve to the emission device in the field, whether that be sprays, MP rotators, rotors, or micro irrigation. There are three main types of pipe that will be used in an irrigation system for both laterals and the mainline: PVC or polyvinyl chloride, PE or polyethylene, and HDPE or high-density polyethylene. PVC normally comes in 20-foot sticks from your distributor. It is most commonly found in a rigid hard plastic form, and some manufacturers also produce flexible PVC that comes in rolls or coils in various lengths. PVC will most commonly be joined together with a combination of PVC primer and PVC solvent weld solution. This process is commonly referred to as gluing, but in fact, it creates a chemical reaction to fuse the two pieces of PVC together. Primer begins the chemical reaction that softens the PVC and provides an evenly prepared surface for solvent cement to be applied for the chemical fusion of the two pieces. PE, or polyethylene, is a flexible, less rigid pipe, normally thinner walled than PVC, and is commonly used in cold weather climates or where pipe can be pulled through the soil using a vibratory plow. Polyethylene pipe requires insert fittings, also known as barbed fittings, and pipe clamps to keep the tube fastened securely to the fitting. HDPE, or high-density polyethylene, is another commonly used pipe type in irrigation. While HDPE is not commonly used on residential properties, you'll find it used in larger commercial applications. It requires more practice and labor time to install. Common terms used for connecting or fusing this type of pipe are butt fusion and electrofusion. Visit an HDPE manufacturer's website to learn more about its proper use and application. Here are some common things to remember when choosing what type of pipe to use for your mainline and laterals. Mainlines commonly remain pressurized 24/7, while lateral lines are only pressurized when a station is running. This will be important to remember when selecting between Schedule 40 and class pipe. The number on class pipe, for instance, Class 200 or Class 315, indicates what the pressure rating is for that type of pipe. Class pipe will normally be very thin-walled at small sizes, and wall thicknesses will increase as pipe sizes increase. The schedule in schedule pipe refers to the wall thickness of the pipe. Schedule 40 is thinner walled than Schedule 80. In Schedule 40 pipe, the wall thickness remains constant in all pipe sizes. For lateral lines, it's a common practice to use Class 200, although some installers may prefer to use Schedule 40 pipe to stay consistent with the pipe that they are using throughout the whole installation. Class 200 pipe at any size has a pressure rating of 200 psi. If you are irrigating a project with non-potable water, it is recommended and sometimes mandated by local code to use purple pipe. Purple pipe will indicate that the water that is traveling through it is non-potable and should not be used for drinking fountains, hose bibs, or any other connection that someone may possibly drink from. This type of pipe is normally labeled with one of the following: recycled water, reclaimed water, or non-potable water, and all will have a do not drink warning printed on them. Ultimately, it's important to read the plans carefully to determine what pipe is being specified for the installation. It is important to read the specifications and construction details on your plans to determine what the proper depths of each pipe should be before trenching for mainlines and laterals. For mainlines, An industry standard for most residential installations is 12 inches deep minimum to the top of the pipe, while commercial installations should be 18 inches minimum. When installing laterals, a good practice is to install them at 8 inches deep to the top of the pipe for residential installations, and 12 inches deep for commercial installations. It's easier to dig a little bit deeper than you think you need, rather than to return later, remove the pipe, and retrench. These suggested depth numbers are based on many variables, including the job location. Be sure to understand the local codes and practices when deciding on pipe depths. When laying the pipe in the open trench, be sure to install the pipe with the writing facing directly up. Getting in the habit of installing pipe this way will make it easier when the inspector comes to take a look at the installation of your irrigation system. The inspector will expect to see the type of pipe that you use to make sure that it matches the specifications and detailed drawings on the plans. If you are installing pipe that has bell end fittings, you should always connect each length of pipe using the bell end fittings and cutting into the pipe where a T, ball valve, or other fitting may need to go. All piping in the system should be sized according to the amount of water that will be passing through it, always maintaining a safe velocity of flow. Moving water from a faraway source to individual locations is an innovation that has been used for centuries. These days, techniques are more refined, but the result is the same: a long-lasting, well-functioning irrigation system to support healthy landscapes. Mainline and laterals are the backbone of an irrigation system. When you begin your irrigation project, pick your pipes according to their function and read the plans to ensure that changes of pipe size in the field occur where noted on the plans. Thanks for watching.